Semi-supervised, unsupervised, reinforcement learnings are feedings to the machine. Then machine is understanding your terminology, it is replying to you. So that is your main 5 days bootcamp objective. You should focus on these learnings. The last one is deep learning. The last one is deep learning. For implementing all these learnings, we need a platform. Right? The platforms are this one. Python platform, R platform, SPSS, SAS, Veka. Guys, just for understanding, I will give a small example. Python or SAS is like a kitchen platform type. Everything is available in the kitchen room. It's called libraries, APIs, plugins. You know what is the plugins, but you don't know how to cook the product. Can you make the right product? You should know how to cook it. Those are all algorithms. That's what all the content. Regression, logistics regression, SVM, decision tree, random forestry. So many cookings are there. If you're strong in cookings, your product is good. If you're poor in cookings, your product is tasteless. You want to make a good product, you want to create a good product or bad product? Come on guys, please. Then you should focus on the machine learning subject. Okay, pin drop sound. You should not avoid even small event. You are missing so many things. Got it? So for implementing all the machine learnings, this is that all top-end models. So I will share all this material to everyone. This is the complete bunch of models. We are focusing on only few models. So remaining models, you have to implement your own. I can show how to make a butter chicken. You have to cook pepper chicken, remaining chickens. Only one cooking only I will teach you. Remaining cooks you have to do. Nobody will help you. Today your professors are helping. In real-time industry, who will help you? Nobody will help you. You have to improve it. So there is a different kind of algorithms we are discussing. Different kind of learnings. Functional learning. It is called regression. If the data is a numerical data, dependent variable is numbers, your target is numbers, we are working on regression models. Your target is a class, categorical data, character data. We are focusing on classification models. Guys, data is two types, A to Z, 0 to 9. A to Z, 0 to 9. 0 to 9 data is a regression, A to Z data is a classification. It's very simple. It's not a complicated, it's not rocket science. Simple. A to Z data prediction, you are using classification models. 0 to 9 data predictions, you are using regression. This is the classification models, this is the regression models. And forecasting models is there, it's out of our syllabus, no need to focus on that. Then unsupervised learning techniques, dimension reduction, cluster analysis, which is available in your books. Unsupervised learning techniques. Got it? Semi-supervised and other supervised. Those are all the techniques, all the machine learning and AI techniques. But in this short term, we can't fulfill all the techniques, only few only. Only few techniques only, which is very most important for your campus interviews and job recruitments and your final interviews. It's really helping. Those only we are focusing. Fully career oriented, only career oriented, job oriented. How to get the more packages? So when we are going for corporate companies, present I'm working for IBM and Renault, Nissan, Benz company. I'm consultant for all the top companies. We know what the employees are facing a problem. Okay, so that you have to overcome. Then your final campus, final recruitment will be easy to you. You can get more and more packages. There is a lot of demand, high demand. Be proud yourself. You are so lucky, guys, to take the AI and ML course. It's a highly demanded course. So guys, This is your deep learning formula. This is your deep learning formula. 1 by 1 plus, excuse me please, 1 by 1 plus exponential of minus function x. Function x is either regression, either weights, either beta values, either other values. So this is deep learning formula. 1 by 1 plus exponential of function x. Deep learning formula. For understanding this deep learning formula, we need a logistics regression. That is 1 by 1 plus exponential of minus regression. For understanding this regression, you need the regression alpha plus beta 1 into x1 plus beta 2 into x2. So regression and logistics regression is a machine learning, and deep learnings are ANN, RNN, CNN. That is called AI. Deep learning comes under AI. Regression and logistics regression comes under ML. So the combination is ML and AI. Wherever you see ML and AI, both are continuation words. Machine learning and artificial intelligence. After machine learning only, AI will come. So if you want to becoming experts in AI, you should know the machine learning. If you want to becoming expert in the machine learning, you should know the inferential statistics. That is a dependent. Probability mathematics. To becoming expert in machine learning, you should know these techniques: variance, covariance, maximum variance. Excuse me, any control person is there? Faculty, any faculty member? So please, somebody is doing their own works. Please monitor them. You only. Yes. I told very clearly, pin drop sound. Focus on my subject. Okay, after 30 days, before 30 days back, they took my appointment. Okay, so utilize these services. It's not academic level, maybe you can take a reference from your friends and you can. But it is a good, rare opportunity, good opportunity for working on the real projects. For understanding logistics regression, we should know this inferential statistics. Note down, or else we are sharing all this material in laboratories, just refresh it. Because without the statistics, impossible to apply machine learning techniques. Variance, bivariate, univariate, multivariates. Variations, variate techniques. Those variating techniques you are deriving from probabilities and statistics. So that is the way statistics, mathematics linked with the machine learning. Got it, my point? Statistics, mathematics linked with your machine learning. This is the probability, continuous probabilities, discrete probabilities. It's all your academic days techniques, right? Do you heard about the continuous probability, discrete probability? Intermediate? Guys, it is there? Probability is not there? So, academic level, maybe you are doing some formulas, calculations. But industry level, we should know why these techniques. Industry level, we should know why these techniques. Whenever you know the statistics, mathematics, then your machine learning is dead easy. It is called future engineering and future extracted techniques. So machine learning person, they should know how to do the future engineering, future extraction for your business data, for your product data. So those techniques we are discussing one by one. Why Python? Why can't it say other software tool? 30 years back, Pascal. 20 years back, C, C++. 10 years back, Java. If you see, every decade, one coding is dominating. It's a true or false, you can analyze yourself. Maybe before your birth, Pascal is there. Later on, C, C++. Maybe you are the C, C++ time, maybe you are doing LKG or UKG. No. So then you are the Java person. Java person time means maybe 5th class. Your date of birth are 2000 around, na? Huh? Oh my God. Then R days, you are the R days. So you are so lucky, guys. You are so lucky because you are writing too much code, but you are writing only one line code. See, the difference is Pascal is taking 100 lines code for one small algorithm, C, C++ taking 50 lines, Java is taking 10 lines, R is taking 5 lines, Python is a 1 line. Python is a 1 line. See guys, for every generation, for every 10 years, one tool is dominating. Then 2030 also another tool is coming to the market now. Can you guess what will be the tool? Indirectly your VC told. The tool name is Go, Go, Google tool. No need to write the programming. If you are speaking, it is giving coding for you. Already new generation started. So no need to much coding. So we are writing too much code. But now you are not writing any much code. Only libraries you are importing. One line statement. So for one line statement also you are fast forwarding for all the things. Your generation is very dangerous generation. So when we are studying, there is no technology we are following. But you have all the things. If you like it, you are watching. If you are not liking, forward. You are all the forward batch. So during this, your work is easy, but missing concepts also too much. Compared to other generations, you are very smart people. Knowledge-wise, technology-wise, you are very smart compared to your previous. They are doing very hard work, but you are doing smart work. Smart work is important than hard work. If you combine both smart work and hard work, you are the winner. That is the market trend. Be smart along with the hard work. Don't do complete hard work. Do the smart work. So I will give one example. One professor find out one invention. So he is publishing across the global. For every time, along with his driver, he is going to the presentation. One day driver is asking, sir, from the last 1 year, you are publishing this article. Every workshop you are saying the same thing, same thing, repeating. I by-hearted whatever you are saying from the last 1 year. Give me one chance, I will make a presentation today. So he told, you are the driver, how can you deliver it? Sir, I am following you, give me one chance. So then driver came to consult, it's a scientist place. Scientist came to driver place. So then everybody say welcome to the driver. He started a presentation. One guy raised a question. So dear scientist, this is my problem. So you are asking silly problem. For silly question, my driver will answer, not me. So that is a smart worker. Driver is a smart worker. Scientist is a hard worker. So you are asking silly question, my driver will answer for your question. Got my point? You be like that. Okay, don't be a driver, don't be a scientist. Combined of the both together. So your generation is so lucky generation. Everything is available. Everything is available. So utilize it in proper way. So the future tool also I'm telling, the tool name is Go. Your next generation people will too much enjoy. So no need to write the programming. If they're writing the concepts, it's generating coding already. The work is going on. Rattle tool is there. Rattle, R-A-T-T-L-E, competitor of the Python. We are working on the Rattle. Rattle, Python, all are the snake names. But which is the poison snake, Rattle or Python? Python, no poison. Rattle is a poison. Snake is very small. Okay. Rattle, Python working on where? Anaconda. So funny ga untundi kada? Those are all applications are working on the anaconda. Anaconda is a big snake. In anaconda, spider is there, orange is there, rattle is there, R is there, Jupiter is there. Am I right? Are you proficient with the Python? Anaconda? So why they are making all the nature names? because nobody will file a case against the nature. So if you are using my company name, I can file case against you. So who will file case against Rattle, Python, Hive, Pig? Pig is a big data. The pig symbol is a Hadoop symbol is a elephant. Elephant is a big, big data. In elephant, pig, Mahanto, some tools are there. All the tool names are animal names, particularly pig. Pig, why they naming a pig? Pig doesn't know how many babies it is giving. So, if you go for the deep level, all are National Geographical Channel names only. It is true, all National Geographical Channel names, Rattle, Python, Spark, Jupiter, okay, Scala, all are nature names, Veka, different names. So this is the tools important for the coming days. So we need a tool, knowledge, and machine learning knowledge. You know the machine learning, but where you are implementing? On the tool only. These tools, that's why Python tool is a one-line statement. Present generation, this is the biggest kingmaker. No competitor for the Python. No competitor for the Python. See guys, for implementing machine learning, we need a statistical knowledge and a mathematical knowledge. Am I right? Statistical knowledge and a mathematical knowledge. What kind of statistics is required? What kind of mathematics is required? We should know that. It's a little boring subject, but it's not a boring, it's a life. Everybody can do the machine learning. Just import the library, apply it. X training data, Y training data, splitting the data, model validate it. Entire the programming is 8 steps only. But what is the background of the 8 steps is important. In interview, they won't ask all these 8 steps. You can by heart it. But what the mathematics behind of this is important. So that subject I'm going to teach right now. So now, whenever you have the data, you have to visualize it, you have to summarize it. That's the first step. Visualize the data, summarize the data. If you see your books, Matplot, Seaborn, in your handbooks, Matplot, Seaborn is there. Why should I visualize the data? Why should I summarize the data? For understanding patterns of my data, how my data is behaving. So you are the doctors, you are doing operation. So directly you are doing operation. Before what you have to do? Come on, what you are doing before operation? Validation, testings, blood samples, repeated tests. Whenever patient is normal, for operation, not a normal personality. Whenever the patient is normal, maybe sugar, BP, everything is controlled, then you are doing operation. Data also the same thing. The data should be ready. If you are giving good data, machine will give the good result. If you give the bad data, it will give the poor result. So you should give the good data. How do you know whether it's a good data or bad data? With the statistical techniques, with the mathematical techniques only, you can understand this is the good data, this is the bad data. Right, guys? Those are all the statistical techniques. If you want, you can note down in all the techniques. Data types, central tendency, dispersions, 5-number summary, distributions. Everybody knows about mean, mode, median, right? Many people knows about mean, mode, median. You should know where to apply the mean, where to apply median, when to apply mode. For implementing all machine learning techniques, before that, how to do all these jobs. It's mandatory jobs. So don't underestimate the statistics. Without statistics, there is no machine learning. No machine learning. Got it? Once you have a data, you have to do the dialysis on the data. So how doctor is doing dialysis on the patient, validation on the patient? Same steps you have to do with the help of statistics. The statistics are mean, median, mode, weighted mean, geometric mean, harmonic mean, trimmed mean, upper mean, lower mean. It's not it's not a new techniques, it's all old techniques only. At the same time, come to standard deviation, variance, minimum, maximum, and etc. techniques. Those are all the visual summary techniques. Visually, you should know how to evaluate the data. Visual techniques also very important. Those visual techniques guys, note down all these techniques. Don't need to try anything, just remember it. While you're doing machine learning, you can recollect it. How to visualize numbers data. Got it? How to visualize numbers data. How to visualize character data. That is our concept. If it's a numbers data, do the histogram. Do the histogram. Why should I do this one? What is the importance of this one? Enti? What is? So, generate a histogram. For which data? Numbers data. Why we are doing this one? Whenever your data is following bell shape like this, your data is good. Whenever your data is following like this, your data is good. If your data is not following this shape, something is wrong in your data. There is outliers. There is missing data. There is NA values. Your data is not appropriate. You can't build a model on such kind of data. Right, guys? So which tool is telling, which technique is telling? Histogram. For which data? Numbers data. It's called frequency distribution. The second one, box plot. Box plot is for finding outliers or data quality. Histogram also data quality, box plot also data quality. Your box is having dots, maybe upper level, lower level, there is outliers. You have to go back and repair the data. So those are all repairing the data for making good data for the machine learning. You are making a good data, you are preparing a good items. See, you have so many vegetables. Damaged vegetables you are considering to cook the product. How you are cleaning? The same process. Simple. Just you are filtering the vegetables. Bad vegetables you are keeping side, good variables you are considering for make a product. It is also like that. Got it? The third one is your data can follow histogram or your data can follow skewness and kurtosis. One is left skewed, another one is right skewed. Left skewed limitation minus 0.80, right skewed limitation plus 0.80. Whenever your data exceeded plus or minus 0.80, something is wrong in your data. So our coordinators will show all those things in your laboratories. Whenever you have a data, apply the skewness. Simple. Data dot SKEW bracket begin. It will display the skewness. Data dot KURT bracket begin bracket end. It will display all the kurtosis. Data dot hist bracket begin. PLT dot hist. Okay. So PLT dot box. It will directly it will display because with a single statement. But what is the story? The story is how your data is behaving, either normal, either abnormal. If it is abnormal, you are repairing. If it is normal, you are moving forward. So like each and every variable, you have to do this practice. I shared case studies, last case studies. You can follow the same case studies, right? Complete Python code is available. Whatever the concepts I'm teaching here, apply it. That's why I'm asking to make a notes. Got it? First, identify which is the numbers data, which is the character data. If it is numbers data, visually do the histogram. Histogram should follow tree shape or bell shape. If it is not following bell shape, at least it should follow this shape. If you combined both together, it's a histogram only. Skewness means half of, left skewed and right skewed. It can be also good, but the limitation of the data plus or minus 0.80. Please remember all these key points. In interview, they will ask these questions. Suppose you are building a product. Before building a product, how you are clearing the data? Tell me one or two techniques. You can tell all these techniques, data cleaning techniques. So guys, tell me what is the skewness range? Plus or minus 0.80. Plus means positive skewness. Minus means negative skewness. If the value exceeded, there is a wrong. Some outliers are there. You have to find out where is the outliers. Got my point, dear participants? Guys, 10 minutes tea break. Okay, na? Be relaxed, come back. Thank you.
Quickly take a break and come back fast. Hello? Sit at your places. And whatever sir is going to tell you, please note down the key points. Don't use your phones during session is going on. Unnecessary things, don't do it, please. I will seize your phone if I see now. Whatever sir is discussing here, whatever the steps are there to write the algorithm, how to proceed, you write step by step things. It will help you a lot in your projects.
Yes, guys, welcome back. See how to visualize the numbers data, how to visualize the character data. That is our afternoon session. First, histogram. For which data, guys? Numbers data. Why we are doing all this? To check how your data is behaving. To check how your data is behaving, we are using histogram. When the data is not following proper histogram, something is wrong in your data. Because you are going to build a model with good data. If you are building a model with bad data, your outcome is bad. Poor performance. So that is the reason for doing all these activities. This is one kind of technique for visualizing your data for validation. It's called data validation. So then, box plot. Box plot is for finding same outliers for numbers data to detect the outliers, followed by the box plot. If the box plot looks like this, your data is good. Your box plot is having some plus or minus range exceeded, there is outliers. Again, go back to your original data, clean the data, validate the data. Your data can follow at least either skewness, either kurtosis. If you make a half of the histogram if you make a half of, it's becoming left skewed and right skewed. The range is plus or minus 0.80. As per the North Carolina State University guidelines, if any data is exceeded plus or minus 0.80, there is outliers. Stop it your process, go back to your original data, clean the data, come back and make into process. End of the day, you are making a product with good items, not bad items. For deciding whether it's good or bad, those techniques are helping if it is a numerical data. If it's numerical data, this is the techniques. Kurtosis, your data can follow histogram, your data can follow left skewed, your data can follow right skewed, but it should be within the limitation. Your data can be leptokurtic, platokurtic, and mesokurtic. Mesokurtic is a kurtosis will be 0. If kurtosis is 0, your data is very good. If the data is a platykurtic, which means skew kurtosis will be -3. The data is -3, up to -3 is good. Above -3, -4, -5, -6, -7, -8 is bad data. Again come back, minimize it, reduce the error, then proceed it. Got participants? As a machine learning person, you are feeding good data to the machine, not a bad data. Okay, for deciding either good or bad data, those are all the techniques, key point techniques. Note down these techniques all. Then scatter plot. Whenever you are comparing the two variables, do the scatter plot for finding relationship. Finding the relationship. Okay. One is X variable, another one is a Y variable. If the relation is strong, the prediction will be very strong. Relation is less, the prediction is poor. This is one kind of techniques for checking the two variables. For checking the two variables, more than two variables is a covariation or multi-scatter plottings. Only two variables, scatter plotting. Multi-scatter plotting looks like this. Multiple variables you are comparing. Variable to variable you are comparing. Different ways you are comparing. It's called matrix format. 10 by 10 matrix. 10 variables comparing with 10 variables. 1 versus 9, 9 versus 1, 1 versus again 9 always. Always one variable into 9 variables. It's called n minus 1, degree of freedom. 9 variables can compare 8 times. 10 variables can compare 9 times, n minus 1. See, wherever the highest value strongly correlated. Those two variables are having strongly correlated and multi-correlated. It is called multi-correlation. If the two variables, bicorrelation. One variable, no correlation. One variable is unique, no comparison. So the dark color is the highest correlation. The light color is the least correlation. Either positive, either negative, whatever it is. Dark color is strong correlation. Light color is negative correlation. If you see, the correlation lies between plus or minus 1. Correlation lies between plus or minus 1. Plus is the strongest correlation. Minus is the strongest negative correlation. One is going up, one is going down. That's negative correlation. Example, sales and advertisement. What is the relationship of the sales and advertisement? Positive, generally positive. If advertisement is increasing, your sales also will increase. If your advertisement is decreasing, your sales will be decreased. One is increasing, another one also increasing. It's called a positive relation. Negative relation means your competitor is increasing, you are decreasing. For you and your competitor, always negative correlation. Through scatter matrix, through correlation plots, through multi-correlations plots, you can find out the relationship of the multiple variables. This is one kind of data validation techniques before ML, before AI. Got it? It's not a direct dumping the data, converting into testing, training. It's not like that. You should give the good data. Heat maps. Large size is a high frequency. Least size is a least frequency. K means cluster. So different areas. If any observation is too much distance, it's an outlier. Everything should be close together. Through K-means clusters, you can identify outliers. That's called KNN model, K nearest neighborhood model. Cluster correlation, same. Correlation, but clustering wise. Different clusters. I have 100 variables. Among the 100 variables, 10 groups are there. 10 variables are one group, 10 variables are one group, 10 variables are one group. Group to relationship through cluster analysis. Those are all numerical data validation techniques. Am I right? We will share this material to all the participants. Please follow it. Key points you can note it down. Key points only you can note it down. So now guys, those are all visual techniques for which data validation? Yes. If it is a categorical data, how to visualize it? If it's a categorical data, how to visualize it? and how to validate it. Bar chart. It's only for visualization, only for summary result, not a validation. Because character data A to Z, missing data is a little typical to do with the character data. Bar chart. Highest bar, most frequency, most occurrence. Least bar, least occurrence. Pie chart. Highest contribution or least contribution. Bubble chart. More bubble is more frequency. Got it? Line chart. For stock market data, we are using always line chart. For applying the line chart, we need a data. Time scaling is important. Either months, either weeks, either days, either quarters or yearly. So one data should be time scale, another data should be numbers. Then go for line chart. So this is the brief visualization before implementing ML and AI. With the help of the visualization techniques, summarization techniques, you can evaluate the data. You can make a normality of the data. You can do the proper validation. Got it? So now, back to this slide. Back to this slide. Those are all the summary techniques for data validation. Now we will discuss one by one. Those are all visual techniques for data validation. This part is clear? Very clear this part? So now we'll go for how to summarize the character, numbers data, character data. Numbers and characters, how to summarize, how to validate it. Got it? Central tendency dispersions. This is the two important techniques. Central tendency and dispersions. Central tendency is a mean, mode, median, upper mean, lower mean, weighted mean, etc., etc. This is the formulas. I'm not focusing on the formulas. Because if you Google it, it's available. But where to apply mean, when to apply mean, why to apply mean. So that is important task. If you know that, where to apply, your implementation is very easy. I'm going to implement these techniques on the small data to conveying you. So you're implementing the same techniques on large data afternoon time. Got my point? For every business data, central tendency is answer always. Central tendency is answer. Whether that answer is a good answer, bad answer is deciding by dispersions. This is the dispersion techniques. Got it? Are you aware of the central tendency? Mean, mode, median. It is enough. The mean, mode, median, upper mean, lower mean, geo mean, harmonic mean, either good or bad, deciding by these examples, dispersions. Now guys, central tendency dispersion is a Tom and Jerry type. Always against. Always against. If the central tendency is all are same, then dispersion is 0. If the dispersion is fluctuating, then mean is disturbing. Got it? So based on dispersion only you are taking a decision making. Your decision is always depends on dispersion. My dear participants, please remember always dispersion should be as much as low, that much is better. It should be as much as low. Dispersion is a very negative keyword in English dictionary. 95% of the English keywords are negative vibration, dispersion, delete, divorce, digging, destroy, dismantle, depression, disprine. Okay, all are negative keywords. So your data should be as much as low, the dispersion. If the dispersion is low, your data is good. Got it? Please remember dispersion. The techniques are standard deviation, covariance of variation, variance, minimum, maximum, range, IQR, skewness error, kurtosis error, standard error, etc. errors. Error should be low or high? Low. If it is low, your data is good. Those are all data pre-process engineering techniques before ML. Tomorrow we will discuss what is ML. Before ML, you have to apply all these techniques. The techniques is a statistical techniques. It's old wine in a new bottle. It's not a new techniques. It's very old techniques. But your generation people are utilizing effectively compared to other generation techniques. If you go for 10-15 years back, all are IT employees. Now, you are IT, but your roles and responsibilities are different. So they are completely working on programming. You are working on the data. Because data is a fuel for the industry. Without data, you can't survive your human lives. Morning, you are saying good morning to your friends. Evening, you are saying good night. Between that, you are doing so much chatting. That is all the data. Based on the data, I can predict what is your behavior. Your sleeping cycle, your wake-up timings, your sleeping times, your lunch times, everything we can predict it. Okay, na? So that is the power of the data. The data is a fuel for the current industries. Without data, there is no machine learning, there is no scope of the data science people. Can you assume without data, world is surviving? No. But 20 years back, without data, we survived. But your generation people cannot survive without data. 2 days, your mobile is off, you are becoming a mad. Okay? So that is the influencing of the mobiles, gadgets, data, finally data. So now, I will take a small example. You are the scientist or analyst. Credit card fraud detection we are doing. Credit card fraud. So as a scientist, how you are troubleshooting this issue with the statistics? Your manager is asking, what is the last month recovery? Based on your historical data. So lakhs of credit card customers are not paying in time their EMIs. So you have to analyze all the data, na? The data looks like this. Small data, because I can't take the large data. For conveying, in this presentation, I can show the small data only. See, this is the 10 members randomly credit card numbers, and that is the default amounts. So that's the default amounts. So one person has to pay 4,000, 5,400, and another person, come on, read it fast. Then another one. Then another one. Yes. What is the average default amount? What is average default amount? Average default amount? Yes, I'm asking one question. Anybody close to 10,000 in your historical data? Anybody? Then how can you believe the mean is good one? Mean is a wrong technique. But everybody knows the mean, na? But implementation wise it's different. Because nobody is close to average value. Why nobody is close to average value? Mean is always giving higher importance. Harmonic mean is always giving lower importance. So in this data, your mean is dominating, which means higher values are dominating. Your higher values are dominating. Small data means you can identify, guys. If it's large data, how can you identify? Is it possible? No. You have tried some algorithms. You have to apply some formulas. Okay. What is the mean? Speak about loudly, please. Speak loudly. What is the median? What is the mode? Geo mean? Harmonic mean? So majority techniques are recommending nearest to 5,000. Only one technique is suggesting 10,000, which you are believing. Majority techniques, na? Majority, of course, somebody is a patient, doctor suggested some different tests. All the tests are saying one result. One test is saying another result. You are considering majority lab reports. So majority lab reports are suggesting 5,000 near. Yes, it's close. Can you cross-verify the values? Very close, na? So don't believe the mean always. Don't believe the mean always. Got it? When I'm checking the dispersion, standard deviation is 16,000. Standard deviation 16,000 means it's too much difference. It should not dominate the central tendency, my dear guys. Dispersion should not dominate the central tendency. It's dominated or not? Is it dominated or not? Dominated now, because standard deviation is 16,000. What I told previously, the dispersion should be as much as low, the data is good. If the dispersion is low, data is good. If the dispersion is high, data is bad. The dispersion is high, the values are showing error. But I don't know where is the error. I don't know where is the error. You can identify 57,000 is error. 10 records means you're identifying. If it's 1 lakh records, how can you do that? If it's 1 lakh records, how can you do that process? So there is one library. Import sklearn standardized library. The standardized library is finding outliers. It is called data standardization. Okay. Z-score. Please note down the formula. X minus average by standard deviation. It is changing your careers. Z-score. X minus standard X minus X bar by standard deviation. What is X bar? Average. What is the standard deviation? Yes. This is called powerful data engineering technique. It's a powerful data engineering technique. It's called future engineering techniques. Got it? What is the inside of the future engineering techniques? Average and standard deviation. It's a pure statistics now. Without these two statistics, can you do the future engineering? No. So what this technique is suggesting, if any value exceeded plus or minus 1.96, which is called 95% of the confidential interval, because the alternative hypothesis is acceptable, null hypothesis is rejected because the alpha is less than 0.05. Okay. So that is the real subject. If you go for MS, they will teach like this. Okay, because Z-score is exceeded plus or minus 1.96, which means alternative hypothesis acceptable. There is no evidence for rejecting the null hypothesis because the probability values are close to 0.05, which is non-occurrence. That's why error is more. H1 you are rejecting. Korean movie cinema చూసినట్టుంటలా Netflix Korean లాగా ఉంటుంది ఇది. So make it simple. It's a future engineering technique. Every machine learning person must know this one. Guys, remember only 2-3 techniques. Standardization, normalization, principal component, KNN. If you remember these techniques, you can survive as a machine learning person. Initially, not for the long run. So, when I'm using Z-score, I got some values. Any data exceeded plus or minus 1.96 is the thumb rule. 1.96 is a thumb rule, 2 sigma. The data is outlier data. Which is having more than 1.96 value? Come on, which value? Third value. On what basis? On Z-score basis. The Z-score is called data standardization. Data standardization. Got it? Even 1 lakh records also the procedure is same. Same procedure. 10 lakhs records also the procedure is same. But 10 records I am showing to conveying how it is impacting. Now, data entry person did a mistake. Data entry person did a mistake. So decimal, they missed decimal. Because of the decimal, it's showing in 57,000. Now, when I remove decimal, then it's becoming normal. You see, what is the central tendency, guys? What is the central tendency? All are nearest to 5,000 now. So for machine learning, which data you are using? This side data. After removing outliers only, my data got normalized now. Okay. So in laboratory, we have the bank data, 36 variables we have. Please find out where is the outliers. Lab coordinators where? Please find out where is the outliers for entire the business data. Okay. Python code is available. Steps are available one by one. Just run it. Understand these concepts. Compile what I teach in this session. Afternoon session, what you are doing practice, make a correlate both together. So it's becoming a knowledge. So now, this is outlier. My dear participants, whatever we discuss the statistics and mathematics, official name is called future. It is your content only. It's not our content. It is your course content. If you cross-verify your syllabus, you can understand. sklearn library, how many people are wearing sklearn? So there is a pre-processing inside. Got it? If you start reading that one, it's typical. But when you are following this slide, easy to read it. If you are doing self-learning, it's typical. Somebody is helping, quickly you can finish it. So, the list of future engineering techniques are this one. Tell me how many we know as on time? Skewness you know? Kurtosis you know? Standardization you know? Normalization, pending. Min-max scaling, pending. Min-max scaling absolute values, not completed. So regression, so tomorrow. Standardized plot, visually it should follow the normal distribution. Box plot, we know. So this is the list of future engineering techniques. One or two you can remembering, it's good enough. Because you're two early boards. So at least four theories there. At that time you can becoming expert. So I don't want to push too much subject on this 5 days. More simple concepts and effective concepts with the practical case studies implementation. So now, what is the skewness range, guys? Plus or minus 0.80. Exceeded, need repair. Come back, identify outliers with the z-score, remove it, automatically it will adjust. If it is not adjust, just leave it. Don't remove the variable from the model. Okay? This is the details about the skewness and kurtosis. Is it clear? How many people are having specs like me? Please raise your hands. You know what is the background of the specs technique? Skewness and kurtosis. Whoever having awards, our power exceeded plus or minus 0.2, guys? Please support me. We're all one family. You, see, and these guys, your power is exceeded plus or minus 0.20? Plus or minus 0.20? 24 or 20? 24. Your power is more than 24, so normalize it. For normality, we are making this one. For normality of the data, we are using this one. So your data should not be much skewed, much kurtosis. So when data is going for one side, too much skewed. All you can do experiments in laboratory times. Simple, only one formula. Data dot skewness bracket begin bracket end. It will give the result. But the skewness understanding is entirely different. So for eye test background, the skewness kurtosis is there. Can we do one live example? Be ready for everyone. Can I do one live example? Okay. I will predict where is your heart. Now only I will predict where is your heart. Okay, guys, please be ready. Take one finger, make a stride to the nose, maintain the little distance. Everybody, please excuse me. Everybody. Close one eye. Close one eye. Close another eye. Close one eye. Close another eye. మీ తల కొంచెం వంకర పోయినా టింకర పోయినా అది కుదరదు, స్ట్రైట్గా పెట్టండి. రైట్. క్లోజ్ వన్ ఐ, క్లోజ్ అనదర్ ఐ. వెన్ యూఆర్ క్లోజింగ్ లెఫ్ట్ ఐ, ఇట్స్ మూవింగ్ వెరీ ఫాస్ట్. గాట్ ఇట్? వెన్ యూఆర్ క్లోజింగ్ రైట్ ఐ, ఇట్స్ మూవింగ్ వెరీ లిటిల్. సార్ ఏమైంది మీకు? ఎస్, డూ ఇట్. టెల్ మీ ద రిజల్ట్. Close this eye. See which eye is moving very fast? Left is moving very fast. Why not right? Anybody is having right is moving very fast? Anybody, one person? That person, body organs are right side. Because of organs, your heart is left side, everything is left side. Because of this, practically if you see, please don't disturb. Practically if you see, one eye is going very fast, one is very less. Am I right? What else? Did you get that experiment is true? You got it? So which eye is moving very fast? Please, now it's enough. Which means left side skewness is more, because in your body all organs are left side only. ఇప్పుడు చేయని వాళ్ళు ఇంకా చేస్తారు, చెయ్యండి ఎవరైనా మిస్ అయిపోతే. ఇఫ్ ఎనీబడి ఇస్ మిస్, ప్లీజ్ డూ ఇట్. నో డిఫెక్టా? మీకేం తేడా తెలియట్లేదా? కూర్చున్న పొజిషన్ పర్ఫెక్ట్గా ఉంటే ఆటోమేటిక్ తెలుస్తుంది. స్ట్రైట్ లైక్ దిస్. క్లోజ్ వన్ ఐ, క్లోజ్ అనదర్ ఐ. If anybody is not having this one, please go and meet the doctor immediately, because your organs are middle or else right side. Okay na? So please don't tire. Otherwise your heart is very small. So left side eye should fast move, very fast. Right side should be very low. Am I right? You got it or not? You got it or not? What about you guys? Because you are the normal. We are the normal like a data. If you are abnormal, we need a repair. No problem, you can practice it. See, your data also follow like this. The spreads background technique is this one. But practically, when the heart is having middle, the eye is not moving too much. Equally it's moving, because the normal distribution is the central. If one eye is moving very fast, your organs are that side. Maybe right or left, I don't know. You make it self-practice. Don't tell to others. Go for evening. Go to home and recheck it once again. 99.99% significantly all our body organs are left side. That's why if anybody got a stroke, left side only happening. Because overburden this side. Got it? So that is the impact of normal distribution. Which is the beautiful picture in the world? Mona Lisa. Why Mona Lisa? Because seriously, this is the real. I'm not taking, it's not a joke, I'm not doing time pass. Please, guys, the Mona Lisa picture is following exactly normal distribution. Normal distribution. The world, ఏమంటారు దాన్ని, వరల్డ్ ఐశ్వర్య రాయ్, మిస్ వరల్డ్, మిస్ ఇండియాస్, in the Nikon cameras and the megapixels should follow the normal distribution. Apple symbol is following exactly normal distribution. If your face is following exactly normal distribution, you are becoming heroine or you are becoming hero. Literally note down it. If you see the Trisha face orally, you will get vomiting. Because her face is following normal distribution. It's matching to the pixels. In that camera, there is a pixels. So, some people looking was not good when they're taking picture, it is so beautiful. Because the shape of the face, normal distribution. It is not a time pass, it's just I'm not engaging, it's a true technique. So that is the power of the normal distribution. So you are doing the patients, you are doing the humans, you are doing the different things. At the same time, you are doing data also. Your data should follow normal distribution. Okay, na? If your data is going for high level, and కోల ముఖం అంటారు వాడిని, కొంచెం ముఖం పొడుగ్గా ఉంటుందన్నమాట, దట్ ఈస్ కాల్డ్ లిప్టోకర్టిక్. ప్లాటోకర్టిక్ గుమ్మడికాయ ఫేసు. గాట్ See, if the face is like a leptokurtic, it's a doskaya but the face, it's a tail. Because the data is following skewness, your data should not follow the doskaya but the face. Okay? At the same time, your data should not follow gummadikai. Pottimakku antaru. So, it should not exceed it. If it's exceeded, you are saying the person is looking like abnormality. Am I right? The person is looking like abnormality. If you have more money, you can go for surgery to make a normality of your face. Facilities are available. Facilities are available. We know what happens for the so many film actors. The surgery failed, gone away. For they're trying to make a normality. You are making a normality of your business data. They're making normality of their faces. But the background techniques are clear statistical techniques. Do you remember before fasting, after fasting, sugar test? The sugar test background technique is paired t-test. Paired t-test. Before and after, what is the measurements? Based on that, we can measure the sugar levels. Those are all the statistics only. Okay? So there is a big subject in biostatistics in MBBS. The techniques are there. Now, machine learning persons are utilizing these techniques. Simply, instead of using leptokurtic, platokurtic, mesokurtic, only rendu gurtu pettukondi. Okati doskaay, okati gummadikai, another one is apple. Apple. Apple is what? Normal distribution. So if you have the camera, make it, test it, you can understand. For that, he is doing some adjustments. That's it. So for making normality, I'm using specs. Some people are not having because their eyes is normal. But we are having specs because we are abnormal. For making normal, Chulochanal is there. Got it? So, guys, your data should be always normality, not abnormality. If it's abnormality, can you predict the models? Can you do effective models? You can do, but outcome is wrong. So, Yes, back. You need more energy? Huh? Please, half an hour. Ante my classes are boring to you? So please, only at least 30 minutes. Okay, guys. Now I take a small data, now I'm taking 3 variables. I want to make a normality of this data. How to make a normality? Make a Z score. Wherever the score is high, it's outliers. Remove it. Remove it for making a normality. So, my dear participants, if the data is different units, go for standardization. If your data is image data, go for normalization. Your image data always lies between 0 to 255. 0 to 255, always. Am I right? Your business data is 0 to 255. You're converting into RGB data. RGB data looks like this. Make this formula. X minus minimum by maximum minus minimum is called second powerful future engineering technique. Please note down. Got it? Can I show KGF movie too? Yes, I will show now. What is the background of the KGF movie Google search engine? If you are searching KGF 2, it is displaying so many pictures. On what basis? What is the background? Background is a principal component analysis, which is the technique behind of this. So randomly it's taking some numbers. RGB means you're all computer science people. RGB means what is the values? 0 to 255. Am I right? 0 to 255. See, cat converting into data, rat converting into data, and dog converting into data. So different values. You should converting into maximization. Why? See now, all the data into decimals. Previous data so much distance. 255 to 222, lot of distance is there. But here, 18 to 1, there is no much distance. So that is the reason for doing normalization. The background is principal component techniques. The large data, too much large data, you are reducing it to the small. So that is the one data extraction technique. For example, what kind of images you are getting? See, everybody is posting the images in Google with the KGF name. Okay, the Google search engine, all the images converting into RGB data, 255.81. The bytes are very less, na? Bytes are very less means the data is customizing. Like one image data converting into 8 lakhs bytes. 8 lakhs bytes randomly we are picking. The randomization is giving pictures like this. Otherwise your system will take a lot of time to fetch the pictures. So this is the best evidence. All the KGF movies. RGB colors, do you know? RGB. Tell me which color you want now? KGF default is a black color. Go for other color. Blue color. Okay. See, the background color is all are green color. See, simply you are uploading because you are the artificial intelligence persons. You should know. Others should not. Others not awareing, it's no worries. In interviews, if somebody is asking, tell me what is the background of this algorithm means, what is your answer? What is your answer? Data is converting into RGB. RGB data storing into with the numbers. The numbers randomly is picking. Based on the random numbers, all the green color numbers, digits is picking. It is showing like this. So cross verify. Can you check with the blue colors? See, majority background is a green color. This is irrelevant, but why we are getting this one? Because system doesn't know whether it is a KGF hero or somebody. Color is taking picture here. Color is the main important. It's not speaking with any humans. Whatever the RGB colors it's fetching. So system is little, net speed is little low. You can cross verify with RGB colors. Did you test before? Everybody is using Google, but now you can understand what is the background algorithms. Who developed all this? Computer science people like you. Image data. It is called pure deep learning techniques. Deep learning techniques. See, majority background color is complete blue color theme. See, your title is KGF pink color, but the pictures are different. With the KGF title, somebody posted with the different color pictures. System doesn't know. It's only picking with the based on the colors. Now, can you understand what is the technique behind of this? It's all the techniques. If you are making undecimal, it's a decimals, it's becoming entire the data zeros and ones. The decimals data, if you are making a round, it's becoming zeros and ones. Okay. See, 255 to 222, distance is more. 0 and 1s, distance is less, which means data is very less. See, total count it, how many numbers are there approximately? 5 digits into 20 times into 3 columns, maybe thousands. Count it at the same time, which is low data. This is low data. It is called normalization. So your data should be normalized always, your business data. Why 1.96? This is the root cause. End of the day, your data should follow like this. Got it? Your data should follow like this. So tell me, raw data are you using for the business models? No. Final conclusion, if you give good data to the mission, it will give good result. If you give the bad data, no, poor result. Already morning session I told, maybe you are not recollected. So give the good data, good outcomes. Give the bad data, poor outcome. We can't say it's a bad outcome, it's a poor outcome. To get the appropriate data, appropriate result, always you should give good feeding. So your data should follow like this always. Then you're eligible for entering into machine learning. Okay, na? Box plot outliers should be like this. It's outliers. Okay, tomorrow's session I'm going to explain future extraction, future engineering, future extraction. Okay? Any questions, please? Any questions? Right. Thank you. Thank you very much. See you tomorrow, little early. Just a minute. Guys, please hold a second. Afternoon session, bank data is available in your locations. Coordinators will help you. Whatever the concepts I explained, you have to implement it. Helping code is available, Python code. Don't follow the help code. Try to write your new code. Whatever you have written the nodes, simply implement it. You are becoming good data. You can get the good data. So then next class, we are going to build a machine learning models. At that time, you can feel some better. Okay? So bank case study is available. Please focus on the bank case study. Thank you very much. Thanks a lot for everyone.
Thank you. Now we have a break. After break, we will meet at 1:50 in labs. So whichever lab 1:50 we are meeting in lab. So that lab number I will send you. Okay, I will tell you which section, which lab is there allotted. Okay. So probably we have 3 labs. So I will tell you. Take your lunch quickly and again come to lab. Okay, bring your laptops. And whatever material yesterday I shared you, okay, one zip file was there, I think. In that, so many. So you please carry that program and one booklet. Morning session, you might have seen one booklet was presented here. That document is also there in that. So please make sure it should be in your laptop. Okay, thank you.